Hello and welcome to another My Chemistry videos. Today we're going to talk about conversions. We have the Nevada State Science Content Standard here, and our objective upon completion of this lesson, you will be able to correctly convert from grams to moles to atoms and back again when you're given an amount of an element. Okay, you're probably going to need each of these four formulas so that you can complete the equations in the rest of this video. There are four types of problems. You might want to write these down. We're going to be converting from grams to moles. We'll be converting from moles to grams, atoms to moles, and from moles to atoms. You'll need to write these down so you can make sense of what I'm going to tell you here. So maybe stop the video, write them down, and then go for it. Okay, next slide. First type of equation is grams to moles. If you were given 56 grams of nickel and asked how many moles of nickel, you could simply plug in some values from, well, you've got your given here. You're going to plug in your equation, 1 mole of nickel, and on the bottom you're going to put in from the periodic table 58.6934 grams of nickel, which is the atomic mass of nickel. Okay, now these setups are pretty simple. If things are side by side, you're going to multiply them. If you've got things that are numbers top and numbers on the bottom, you're going to divide. This part here is a simple unit conversion. We know that 1 mole of a given element weighs whatever the atomic mass says on the periodic table. So that's why we can convert from grams to moles. Okay, we've got grams of nickel on the top. We've got grams of nickel on the bottom. So legally, we can cross-cancel and get rid of those units. The only units we're left with is moles of nickel. So now we have 56 times 1, which is just 56. And 56 divided by 58.6934 will give us our answer, 0.954 moles of nickel. All right, let's move on to the next one. Now here we have 205.6 grams of chromium, and we want to know how many moles of chromium that is. I've covered up the equation to give you a chance to try and work that out for yourself. It's just the same as the last one we did. Simply write down your given, find out what the symbol is for chromium, and next to it you're going to fill in from the formula that I gave you earlier, and I told you to write it down. You'll need the atomic mass from the periodic table. So here's what you should have, something that looks like this. And we can cancel grams of chromium top, grams of chromium bottom, and we're left with just moles of chromium and some numbers. So 205.6 divided by 51.9961, and you should come up with 3.954 moles of chromium. All right, let's move on to our next type of problem, moles to grams. 0.257 moles of strontium is going to be equal to how many grams of strontium? So we write down our given here on the top, 0.257 moles of strontium. And on this side, this is our conversion again. We know that 1 mole of strontium weighs 87.62 grams. And this again comes from the periodic table. Okay, so this one's a simple multiplication. 0.257 times 87.62, and we come up with 22.518 grams of strontium. Let's move on, give you a chance to do the equation yourself, and then we'll uncover the answer as well. Okay, so we have 68.2 moles of cobalt. So you're going to need to find the symbol for cobalt, you're going to need to find the atomic mass for cobalt, and plug all those in. And when you do, you should end up with something that looks like this. Okay, we've got moles of cobalt on the top, a mole on the bottom for cross-canceling, and again, a simple multiplication leaves us with our grams of cobalt. And we should have 4.019 times 10 to the third grams, or 4,019 grams of cobalt. Moving on. Atoms to moles. If we have 3.5 times 10 to the 27th atoms of calcium. We want to know how many moles of calcium that is. Now these problems are a little bit easier in one way and a bit more difficult possibly in another. We don't have to look in the periodic table to find out what the atomic mass is for any elements when we're just going from atoms to moles or from moles to atoms. But we do have to deal with this scientific notation in our calculations. We'll always, when converting from atoms to moles or moles to atoms, we will always be using Avogadro's number. It's a constant, 6.022 times 10 to the 23. We know that in 1 mole of a substance, there are this many things. In this case, we're talking about atoms. Okay, so on the top we have atoms of calcium. On the bottom we have atoms of calcium, so we can cross cancel. And what we end up with is moles of calcium and some scientific notation, and we're doing division. Now if you have a calculator, scientific calculator, we can put some parentheses around this on the top, parenthesis 3.5 and times 10 to the 27th parenthesis, and we'll go divided by, this is how you'll enter it in your calculator, and then another parenthesis, Avogadro's number, and another parenthesis. If you don't use those parentheses when entering it in your calculator, you're going to end up with something like an answer that has something like times 10 to the 47 or 49 or somewhere around there. But if you entered it properly, this is what you should get. 5.812 times 10 to the third moles of calcium, or 5,812. Okay, moving on. Here again you have the opportunity to set up the equation yourself. 60,235 atoms of mercury. How many moles of mercury would that be? So again, you should end up with something like this. Okay, Avogadro's number on the bottom. We do a little bit of cross-canceling of atoms. We're left with moles of mercury. And we do a little division. And if you enter it correctly, you should end up with something like this. 1 times 10 to the negative 19th moles of mercury, or 1.00024 times 10 to the negative 19 moles of mercury, if you want to be real accurate. Okay, moving on. Moles to atoms, which I believe is the last of our 4 types of problems. 38.2 moles of lead equal to how many atoms of lead? So we've got moles on the top. We'll need to cross cancel. So we put 1 mole on the bottom, and Avogadro's number goes on the top. This many atoms in 1 mole. This is just a simple multiplication problem. Just multiply all those numbers straight across. You should end up with 2.3 times 10 to the 25th atoms of lead. Seems simple, doesn't it? Okay, you try it. Set up your equation. You're given 32.6 moles of platinum, and you need to know how many atoms of platinum is that. So you have an equation, plug it into, and you should end up with something that looks like that. Cross cancel our moles, left with some multiplication and atoms of platinum. If you plug that in your calculator, you should have 1.963 times 10 to the 25th atoms of platinum. Okay, now we've covered all 4 types that we had earlier. There we are. But one last thing you may run into is you may be asked to convert from grams to atoms. And we don't have a conversion for that. Or you could be asked to convert from atoms to grams. And there are 2 ways to accomplish this. So let's take a look at that. First method. You're given this question. How many atoms can be found in 75 grams of gold? So you're given grams of gold. We do have a conversion to go from grams to moles. So why don't we plug into that first? So we have 75 grams of gold, and we have the atomic mass for gold, 1.96.96655 grams of gold. And that's how much 1 mole of gold weighs. So we can do this, calculate, and come up with the number of moles of gold this is. Now if we take that amount of moles, we can plug it into a conversion for moles to atoms. So completing this in the red here, you'll end up with this many moles of gold. Now if we have moles on the top, we'll need moles on the bottom, and converting to atoms, remember, you're going to be using Avogadro's number. So again, some simple multiplication, cross-canceling, you end up with this many atoms of gold. Now this first method, if you're the kind of person that doesn't like to write in units like grams of gold or moles of gold or atoms of gold, so forth, I would recommend you use this method, excuse me. Because if you don't, you're probably going to start mixing up your numbers and come up with a wrong answer. However, if you're conscientious and you do write in your units, then go ahead and give this method a shot. Here we have the same question. How many atoms can be found in 75 grams of gold? And we can convert from grams to moles to atoms all in one shot. This first part in red is exactly the same as what we had before, our grams to moles. We plugged in our 75 grams of gold. We have our atomic mass of gold and 1 mole of gold on the top. Now what we've done, instead of doing that second equation, we can cross-cancel grams of gold, grams of gold. We have moles of gold on the top and we want atoms. So if we put a mole of gold on the bottom, and Avogadro's number on the top, we can just keep on going all in one equation and solve this thing. 75 times Avogadro's number, and then take that and divide it by the atomic mass of gold. And if you remember from the last slide, this is what we had calculated. Exact same answer. Okay, with this knowledge you should be fairly well armed to tackle any assignment given to you about conversions from grams to moles to atoms and back again. Hope this video helped you out, and thanks for watching.